All right, so we do have our free response here. So we're going to be taking a look at that. I also may at the end circle back to the warm-up, kind of the breakout rooms that we did and just kind of take a look at those answers. But we're going to start off with the FRQs here. So this first one, we're given the graph of a function f pictured above, and it's a semicircle, 2 line segments. And then it gives us this equation, g of x equals the integral from 0 to x of f of t. Okay. By the way, if you are watching live, please do be encouraged to use the chat. If you have any questions, let me know, or if you want to know, hey, what if I put something this, or what do I absolutely need to write down to get points? Go ahead and use the chat, and I'll take a look at that and kind of help you out. So this question here is very common when we see something in this form. It's very, very common, and you almost always get a point for writing out g prime of x and writing g double prime of x. So I really, really highly encourage you, like as soon as you see this on part A, make sure that you write down g prime of x and g of x. So I like to do that before I even do anything else. I might write out, okay, g of x equals the integral from 0 to x of f of t dt. Then g prime of x will be equal to f of x. Right, that's that fundamental theorem of calculus. That's where we did the derivative to chain rule. So derivative x is 1 and then plug in, so we just get f of x. And then g double prime of x is equal to f prime of x. So a lot of times, this line right here might be 1 point. This line might even be a second point. So that might be 2 points. Even though you didn't plug anything out in, you might have just gotten yourself 1, even 2 points. So that's super, super important to write that in. When we do take the real exam, the real AP exam, also it's important to write this in your section, in that section of your test book. Don't write it somewhere like up here in this area. They're not grading that. Make sure that you actually write that in section A. Now, they asked us for g of 3, g prime of 3, and g double prime of 3. So for g of 3, that's going to be the integral from 0 to 3 of f of t dt. And we talked about this quite a few times in the video yesterday, where this is the area under the curve, this is the y value, this is the slope. So we're going to do the area under the curve from 0 to 3. That's a quarter circle and a triangle. So this will be above the axis, 1/4 for the quarter circle, pi times 2 squared, and then minus 1/2 times 1 times 1. And so we will get this answer is equal to pi minus 1/2. And just leave that as your answer. For g prime of 3, I like to kind of write g prime of 3, and then I like to write equals f of 3. That way the reader, whoever's grading my test, knows exactly where I got it from. So f of 3 they gave me was -1. And then lastly, we will do g double prime of 3. So g double prime of 3, that's going to be equal to f prime of 3. And this is going to be DNE, does not exist or undefined. Right? And the reason this is undefined is if we look at the slope there, that's at a corner. So we're going to say DNE because the graph of f is not differentiable at x equals 3. So, the graph has a corner. Right, so it's not differentiable because there's a corner on the graph. So otherwise we would have done the slope. Like if this line would have continued down, we would have done the slope there, right? Like f prime of 3, the rise over the run, and just kind of counted it algebraically. But because we made a corner, then that graph is not differentiable. So g double prime of 3 does not exist. Okay, find the x coordinate for each point of inflection. So for each point of inflection of the graph of g. So the points of inflection of g. So a point of inflection for g, I'm going to kind of just write this off on the side, would be where g double prime changes sign. So we want to kind of say here that g double prime of x equals f prime of x. So we're looking for where does f prime of x change. And it's very important that you have your answers relating back to f. Okay, a lot of us first semester on these would state our answers in terms of g, but in this case we don't have a graph of g, we have a graph of f. So even though, inflection point means where does g double prime change signs, we need to talk about where f prime changes signs, because we have a graph of f. So we want to talk about where f prime changes signs. So if we want this to change signs, we want f prime to be changing signs. F prime would be the slope. So where does the slope change signs? Where does the slope change between positive slope and negative slope? So if we look at this graph, we're increasing, increasing, increasing. And then we start decreasing. Then there is a kink here, but it keeps decreasing. And then we increase again. So if we were talking about like possible inflection points, okay, technically, x equals net 0 is a possible inflection point. And then here at x equals 2, there's a kink. And then here at x equals 3, there's a corner. So all three of these are possible inflection points, but it's only an inflection point if it actually changes. So 2 would not be an inflection point because the graph decreased and kept decreasing. The slope, the f prime, did not change. So we increased, we decreased, kept decreasing, and then increased. So x equals 0 and x equals 3, those are inflection points because that's where the graph changed between increasing and decreasing. And why did we want that? Because g double prime is matching up with f prime with our slope. So we will say the graph of g has inflection points at x equals 0 and x equals 3. Now, if you are confused about what to write, the easiest way to write this is to say because g double prime of x equals f prime of x changes signs at those points. You'll always get it right if you write it that way. That's kind of my hint to you. If you're not sure what to put, just say g double prime of x equals f prime of x changes at those points. Some books and some answer keys will say something like because f prime of x changes signs, or because f changes from increasing to decreasing, or vice versa. But really, the simplest, most concise way to say it would just be to connect, g double prime of x equals f prime of x. That's what was changing signs. But we want to make sure that we have both, or definitely at least the f prime, because that's the graph we were given, the graph of f. So again, if you joined a little bit late, it looks like a couple people joined a little bit later. Please do feel free to use the chat. If you're not sure about, would I get points for this answer, or what do I absolutely need to write down to get points, or even just can you go back, or can you explain that one more time, or if you have a question, please do use the chat for those questions. It might help out some of the other people as well. On the closed interval from -2 to 5, what is the absolute minimum? This is a tricky question. This is usually a harder question. And as soon as we see an interval and the word minimum or maximum, we know we're doing absolute, or in this case, they gave us the word absolute. So whenever we're doing this, this is a hard question, and a lot of you guys might not have enough time for this one because it takes a while, but every single person should get a point, okay? The nice thing about this question is there's always at least one free point. Like one basically free, easy point that takes no time at all. And to get that point, what do we want the minimum of? We want the minimum of g. So to get that point, we're going to set g prime of x equal to 0. Now, what was g prime of x? It was equal to f of x. And so we're going to set g prime of x equal to f of x equal to 0. Right? Whenever we have these questions, we always want to be writing out, something like this. One of these three. Right? We want to set g back to f because, like I said, we were given the graph of f. So whenever we have maximums and minimums, right, g prime to 0, but say g prime of x equals f of x equal to 0. That right there, probably 1 point on the AP exam. Now, where did f of x equal 0? Well, on this graph, okay, I'm going to go ahead and erase this, clean it up a little bit. It would be 0 wherever it just crosses the x-axis, right? Where does f of x equal 0? At 2 and at 4, at x equals 2 and 4. Now, technically negative 2 as well, but negative 2 and 5, those will be our endpoints. So we're only concerned about, the inside here. So we would say x equals 2 and 4, right? Those were our two zeros, 2 and 4. Now, if you had said negative 2 as well, they're not going to take off a point. You'll still get the point. So sometimes this is worth a second point. So sometimes this is even 2 points, which is huge, right? And sometimes it's one or the other. But definitely, this is between the two of them, right? Like kind of between the two of them, you'll end up with 1 or 2 points for that. You don't even have to make a table. You don't even have to do anything else. Automatic 1 or 2 points. So that's huge, huge, huge. Please do not miss those points. Like those are points that I want everyone in the class to get. Now the next part is definitely hard. The next part is where we're going to make the table. We're going to put in x. Now we wanted the minimum of g. So this is going to be g of x. And then this is where we put in our endpoints. So negative 2 and 5. And our critical points. So 2 and 4. And so then now we need to say, okay, g of x is equal to the integral. And I believe this was from 0 to x, I think. Yes, from 0 to x of f of t dt. And so this is doing the integral of the area under the curve. And so this is where it is a little bit more work. So the first one, g of negative 2 would be the integral from 0 to negative 2 of f of t dt. And so kind of going back up here on the graph, from 0 to negative 2 is going backwards. Okay, so it's when we go backwards, we flip the sign. So even though this is above the axis, because we're going backwards, it's going to be negative. So this will be negative 1/4 pi times that radius was 2 squared, which will be negative pi. I'll do another color. I'll do blue. Now g of 2 will be the integral from 0 to 2 of f of t dt. This is going forwards. And you can see that's the same shape, so you don't really have to do it. It's just the same shape, but just positive this time. So, it's 1/4 pi times 2 squared again, but it's just positive pi. For 4, okay, g of 4 will be equal to the integral from 0 to 4 of f of t dt. Now, we don't have to redo the 0 to 2 part, right? We know the 0 to 2 part was pi. So, this part was pi. And now let's add on that triangle. Well, it's below the axis, so we're actually going to subtract that triangle. So 1/2 times base is 2 times height is 1. So this is going to be, the previous one was pi, and then minus 1/2 times the base was 2, and the height was 1. Those cancel, so we get pi minus 1. And then for 5, okay, we're going to do g of 5 equals the integral from 0 to 5 of f of t dt. Again, we don't have to, keep showing work that we've already done. We already know that this whole red section, everything up to here, was pi minus 1. So now let's just add on this new section, which is 1/2 times 1 times 1. So I'm going to just kind of do that. We had pi minus 1 already. And let's add on 1/2 times 1 times 1. We're adding it because it's above the axis. That's pi minus 1 plus 1/2. Negative 1 plus 1/2 is minus 1/2. So pi minus 1/2. Now, we wanted to know the absolute minimum. That's the smallest value. Well, all three of these are positive. The only negative one was the beginning. So I like to kind of state both the x and the y values. So I'm going to say the minimum of g, or I could even say the absolute minimum of g, over -2 less than x, less than or equal to x, less than or equal to 5, is at x equals -2, and g of x equals -pi, kind of stating both of them. Or we could say at g of -2 equals -pi. That's probably the better way to say it, is at, I'd probably do that, is at g of -2 equals pi. That's kind of a little bit better. So I got the x value in there and then the result. So these are tricky. These are a lot of time and a lot of work. And this is probably an extra 2 or 3 points for doing all this. Usually it's, 2 or 3 points for doing this. But please, 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 please write that down and make sure you get that point, even if you don't continue and finish the table. Okay, next one is one of these differential equations. And so we're given the differential equation dy dx equals y minus 1 over x squared. And first, before anything else, they ask us to just plot these 9 points. They don't ask us to plot, they didn't put anything there. The reason they didn't put anything there is because that's when x is 0. Kind of going up and down as x is 0. Those are all undefined. Okay, but if they did, just, if they did have points here, you can write them as vertical lines. Or you can leave them blank as well. I like to write them as vertical lines to show them that I did something. But since they said the 9 points indicated, we're going to just leave those blank. So I usually like to start at 1, 1. You can start anywhere, but I like to start at 1, 1. If you want to make a little table on the side, they're never going to give you a table. But if you want to kind of just write one in yourself, you can. So, x, y. Sometimes it just helps me to write it out. So 1, 1. That's 1 minus 1 over 1 squared. 1 minus 1 is 0 over 1. So 0. So I get a 0 here. And that kind of shows me, hey, you know what? If I have y equal to 1, I'm going to get 0. So immediately I can, without even doing anything else, I know those guys are going to be 0. Because anytime I have y, is equal to 1, 1 minus 1 is 0. Now be careful. Don't put a 0 here. That was undefined. Right? 0 over 0 is undefined. Now let's try 2, 1. Okay, 2, 1. 2 minus 1 over 1 squared. That's 1 over 1, or just 1. So I'm going to kind of try to connect an imaginary line here. That's a slope of 1. Then 2, 2. You can do these in your head as well. So 2 minus 1 is 1. Over 2 squared is 1/4. Down 1 over 1, 2, 3, 4. Be kind of connecting somewhere over here. So a very shallow line. Right? Now you could have also written it down, 2, 2. Got in 2 minus 1 was 1 over 2 squared was 1/4. You don't have to write that, but if it helps you, then absolutely write it. Okay. I'll go down to here to my x's being 1 and my y's being 0. So this is 1, 0. 0 minus 1 is -1 over 1 squared is 1. So I get -1. So right here it's, down 1 over 1 or up 1 left 1. So I'm kind of trying to connect it about there. And then at 2, 0, I'm going to end up with -1 over 2 squared is -1 over 4. So it's kind of, we can see it's flipped. This was flipped. Okay. So up 1, left 4, we're kind of trying to connect it there. Very, very shallow line. they're not going to need you to be precise, just as long as this guy here is steeper than that guy there, they're going to mostly give you credit. And then these last two at -1, 2. So 2 minus 1 is 1. And then -1 squared is +1. So this is, again, up 1 over 1. So same slope as that guy. Okay, so those should try to be about the same. And then -1, 0. 0 minus 1 is -1. And then over -1 squared is +1. So these two guys should match up. So that's what your graph should have looked like, or something similar. Next, we have find the particular solution to the differential equation. Now, be very careful that you make sure you're doing the particular solution when they say to. They might say on B, do a tangent line approximation. This one, though, said find the particular solution. So we're going to I like to rewrite my dy dx equals. So I'm going to just come back up here and just rewrite exactly what we had, y minus 1 over x squared. And then we will do times, can I extend that, times dx, extend that, times dx, divide by y minus 1, divide by y minus 1. So that gives us dy over y minus 1 equals, now this is in the denominator. So what I've seen a lot of students make mistakes is they'll do x squared dx. That is wrong. The reason that's wrong is because the x squared is still in the denominator. That's why I kind of like to extend that line. So this is going to become dx over x squared. Now we're going to take the integral of both sides. You can do u sub if you want to, or you can kind of remember the shortcut I was talking about yesterday, which is whenever you get du as 1, you don't really have to do any u sub, right? The u is just going to, it's going to kind of be unnecessary. So this ends up being the ln of y minus 1. But if you want to do a u sub, you can. So I'll show it just for the people who want to do it, I'll show it. Okay. So this would become, I don't need to multiply by anything, I already have 1 dy. So it's going to become 1 over u du. And then over here on this side, I need to bring the x squared up. So it's going to be x to the -2 dx. Then I will take my integral, 1 over u is ln of u, equals, add 1, x to the -1 over -1 plus c. Right, when I add 1, I get x to the -1 over -1. I'll rewrite this as the ln of y minus 1, plugging back in for u. And I'm going to bring this down to the denominator. I'm going to bring the negative out in front. So -1 over x plus c. Now we will do e to the power of both sides to get rid of the ln. And we kind of do that shortcut where we bring the c to the front. That also allows us to drop the absolute value when we bring the c to the front. And this would be the general solution. So if they had asked for a general solution ever, that's our general solution. But then to get the particular solution, we have to plug in our x and our y and solve for c. So x is 2, y is 0. I'm going to kind of do that up here. So, oh wait, first add 1 to both sides. Y equals c e to the -1 over x plus 1. Okay, and now I will plug in 0 equals c e to the -1/2 plus 1. Now, before I can isolate for, here I need to subtract 1 and then I can divide. I'm isolating for c. So e to the -1/2, it's like a number. It's like 2, right? Some students get really confused on this, but kind of think if I had 0 equals 2c plus 1, that would be really easy. What would I do? Subtract by 1, divide by the 2. Right? Same process here. Subtract by 1, and then we're going to divide by the e. So this gives me -1 equals c e to the -1/2, divide by e to the -1/2. And we would get negative 1 over e to the negative 1/2 equals c. And so then I'll just plug that back in to this guy. That was our general solution. I said this was the general solution, was actually that one up there. So this is y equals negative 1 over e to the negative 1/2 times e to the negative 1 over x plus 1. And that is a perfectly fine answer. Now, if you wanted to bring the negative exponent up, you can. So you could also bring that up and make it negative e to the negative 1/2 times e to the negative 1 over x plus 1. And if this was multiple choice, whenever you have an e times an e, think that's kind of like having x squared times x cubed. What do you do with the 2 and the 3? You add them. So you get x to the 5th. We like added those two. So on multiple choice, they may even simplify this to negative e to the negative 1/2 negative 1/2 plus negative 1 over x, which is minus 1 over x plus 1. So that could be an answer, and that also could be an answer. But I wouldn't recommend trying to do that. I wouldn't recommend trying to simplify. I would recommend it's free response. As soon as you get an answer, just leave it and don't worry about simplifying. The only thing that can happen when you simplify, you got two possibilities. One, you simplify correctly, and you get the same amount of points as if you didn't simplify. Or two, you simplify and you mess up, and you lose out on some points that you should have gotten if you had just stopped. So you're kind of just wasting your time with no possible reward. So, that's kind of that. Brandon, I do see your question, so I will go back to it and then we'll come here. So Brandon asked, what if you get really slopes that are hard to differentiate? Like drawing a slope of 3 or a slope of 6. So Brandon, you're talking about, on your slope fields, right? So that's where I was saying is I try to just guess at it. But really, the only thing the graders are looking for, usually on these, it's 2 points. Okay, usually you're going to get 1 point for the zeros. Obviously, the zeros have to be 0. And then they give you 1 point for all of the other ones. And so really all that they're looking for here, they don't care if this actually is a slope of 1/4. What they care is that this is steeper than that. That's all they care about. And then that they're both positive. And here again, they care that this is steeper than that guy, and that they're both negative. So that's really all they're caring about. So if you got you had some kind of a slope field here, and Brandon said what if you got 6? Well, 6 is really hard, up 1, 2, 3, 4, 5, 6 over 1. That's going to be really hard. You can try to guess at it. Just kind of extend it up on your own and try to guess on it. It's going to look really steep, but as long as, say if the next one was 4, well, up 1, 2, 3, 4 over 1. As long as, see how this guy is steeper than that guy? They're not going to take a ruler and see if you actually had it right. Okay? All they care about is that your 6 ended up looking steeper than your 4. Okay. All right, so next, describe all points in the xy coordinate plane for which the slope of the tangent line would be positive. Now, a lot of students see the word tangent and they immediately do x1, y1, and m, which I love. But in this case, we didn't have to do that. They're saying describe where the slope of the tangent line, that just means the derivative. That's a fancy way of saying dy dx is positive. So in order to do this, we want to look at the equation dy dx. So what was our equation? Our equation was y minus 1 over x squared, right? Dy dx was y minus 1 over x squared. Okay. Well, what do we know about x squared? X squared is always going to turn positive. No matter what, it's going to turn positive. Now, it can't be 0, but otherwise, it's going to be positive, right? And they even told us that x can't be 0. So where, basically the denominator is always going to be positive. So we don't really have to worry about the denominator, right? The denominator we know is always going to be positive. So we really care about the numerator. So we want that y minus 1 will be greater than 0. So that means y, if we had 1, would be greater than 1. So we can say the slope of the tangent line will be positive for y is greater than 1, and then just kind of add on, such that x cannot be 0. So that's your answer. So generally, if you get a question like this, describing where it would be positive or describing where it would be negative, generally what will happen is that, if you have a numerator and a denominator, your denominator will probably be x squared, or maybe your numerator is x squared. You can kind of ignore that because it's going to be positive for everything. And then the other side, you would just set it greater than 0 for positive or less than 0 for negative. Next up, we have consider the differential equation. So another one of these, negative 2x over y. On the axes provided, sketch a slope field. So again, this time they have 12 points. And you can kind of write it out, or you can do it in your head. I'm going to show just doing this one in my head. Now, I do want to pick out zeros first, because that's always easy. So if y is 0, I get undefined. So when y is 0, it's undefined. And actually, they left that blank again. So if it wasn't blank, I would put in vertical lines, but they left it blank, so I'm going to leave it blank. Then when x is 0, right, 0 over any other number is 0. So that's a 0, that's a 0, that's a 0, and that's a 0. That would probably be 1 point, and then the rest of them will be the other point. So at 1, 1, negative 2 over 1 is negative 2. So down 2 over 1. And again, just kind of guess at it. Down 2 over 1, it's going to kind of connect to right there. Doesn't really matter, though, how you draw it, as long as it's steeper than something else. Then here, 1, 2. So x is 1. Negative 2 times 1 is negative 2. Over 2 is negative 1. So this should have a slope of negative 1, down 1 over 1. So something like that. Now again, it doesn't matter if it matches exactly, as long as this guy was steeper than that guy. Okay, next, 1, negative 1. So negative 2 times 1 is negative 2, over negative 1 is positive 1. So up 1 over 1, kind of connecting something like that. And then this guy will be plugging in 1. Negative 2 times 1 is negative 2, over negative 2. I think I did that backwards. This should have been, that's why it helps to write these out. Negative 2 times 1 over negative 1 would have been positive 2. So up 2 over 1. And this one was up 1 over 1. So again, these are kind of flipped, right? And this guy was steeper. That was a slope of positive 2 and a slope of positive 1. And then on the flip side, right, I'll kind of write these out so I don't make a mistake again. I'll do this guy first. Negative 2 times negative 1 over 1 will become positive 2. So up 2 over 1, kind of connecting something like that. And this one here, negative 2 times negative 1 over positive 2 would be 1. So up 1 over 1, kind of connecting something like that. And you can see these are reflected as well. So my guess is that these are probably going to be reflected as well. This is probably going to be negative 2. This is probably going to be, and negative 1. So I'll do these in my head. Negative 2 times negative 1 is positive 2. And then over negative 1, we'll turn negative 2 again. So down 2 over 1. Kind of that steeper one. And this guy will be negative 1. B says, write an equation to the tangent line. So not solving it, the tangent line. So on B, we're going to do x1, y1, and m. They give me my x1 is 1, and they give me my y1 is negative 1. And for the m is always going to be the dy dx. Okay, so my m, I'm going to plug in negative 2 times the x was 1, and the y was negative 1. So it's negative 2 over negative 1 is positive 2. So we get y minus negative 1 equals m times x minus 1. So y plus 1 equals 2 times x minus 1. Yeah, that's not a hard point to get. We should absolutely get that point. Then it says use it to approximate f of 1.1. So do y plus 1 equals 2 times 1.1 minus 1. That's y plus 1 equals 2 times 0.1. 2 times 0.1 is 0.2. You don't have to show all of these steps. You can do a lot of this in your head. Then subtract 1. And we get y is equal to negative 0.8. You can box this, or you can rewrite it as f of 1.1 is approximately 0.8. This is a little bit more proper, is to replace the y with f of 1.1. But if you had boxed this, you'll still get the full credit. Okay, you'll still get full credit there. Then it also says explain why the tangent line gives a good approximation of f of 1.1. This is a little bit hard, okay? Normally, a question is going to say, is it an over or an under approximation? If they say, is it an over or an under approximation, you have to find the second derivative and figure out, kind of the second derivative like this, or the second derivative like that, right? But in this case, they didn't ask that. They said, explain why this would be a good approximation. So when we do tangent lines, what happens for tangent lines is if we're approximating, at 1, if we're approximating for 1.1, it's very close. So it's a good approximation for 1.1 because 1.1 is close to 1. But it would be a really bad approximation for, say, x equals like 3, right? At x equals 3, this graph has gone way up. So I would say this is a good approximation for f of 1.1 because x equals 1.1 is close to the x value of the tangent line. This is not a common question. I don't think I've ever seen this asked on the AP exam. But it's just something to kind of think about in practice and make sure we're reading. Okay? Big thing is make sure we're reading. This asks 3 questions. Write an equation, use it to approximate f of 1, and then explain why. So it asked me 3 things. We need to make sure that we answer all 3 of those things. A lot of times students will just stop after one of them and then they'll miss out on other points. The next one says find the particular solution given f of 1 equals negative 1. So find our particular solution. When we see that particular solution, that's where we separate our variables and then do the whole times dy times dx and then take the integral. So that guy shouldn't be too hard. We've done it a lot. So we had dy dx equals negative 2x over y. Okay, again, please feel free to use the chat if you have any questions or any comments or if you're just bored. Okay, now the y is on the denominator. So to cancel out a y on the denominator, we actually multiply up to the numerator. So we get y dy equals negative 2x dx. Take the integral of both sides. And so that would be y squared over 2 equals negative 2x squared over 2 plus c. So y squared over 2 equals negative x squared plus c. I'm isolating for y, so I need to multiply every single term by 2. But remember, 2 times c is just going to give us a new c. It's just going to give us a new c. It's not the exact same c, but on the AP exam, they're okay with us just writing it as c again. So sometimes textbooks, they will write this as plus, c1, because it's like a new c. but on the AP exam, you can just write as plus c again. It's fine. Then we're going to take the square root of both sides, and we will end up with y equals plus or minus the square root of negative 2x squared plus c. Now, it's important to write the plus or minus in the first step. The reason you want to write the plus or minus in the first step is because that is the general solution, right? But then once we go in and we plug in this initial value f of 1 equals negative 1, we know the negative side is going to be, the y is always what we're looking at. So this will be y equals negative square root of negative 2x squared plus c, right? And again, the reason, I know I've gone over this in class, but the reason for that is this is the positive square root side, and then this is the negative square root side, and you have to only have one of them. Otherwise, it wouldn't pass the vertical line test. It wouldn't be a function. So if your y answer is negative, it matches up with that. If it was positive, it would have matched up with the other side. So now we can go ahead and plug in. So for y, we're going to plug in negative 1. And for x, we're going to plug in positive 1. Then I am going to square both sides to get rid of the square root. Make sure you square that negative with it. Square that negative with it. Otherwise, you could divide the negative over as well. Negative 1 squared turns to positive 1. Then the negative goes away, and the square root goes away. So we get negative 2 times 1 was negative 2, by the way, plus c. Add 2 over, we get 3 equals c. So then we will plug that back in there. So y equals negative square root of negative 2x squared plus 3. Then we did have a couple other just kind of questions to consider and to help out. So I'll go through these quickly. So these are just other things that I could ask, other topics I could ask. So if we had big F of x equals the integral from 3 to x of f of t, and then this is the graph of little f, then we might want to answer some of these questions. So, big F of 2 would be the integral from 3 to 2 of f of t dt. So that's the area from 3 to 2, right? That's kind of a weird area. We're going backwards, but it's below, so we're actually going to get a positive answer. And you can count squares here a little bit, but not really. So I'm going to split this into a rectangle and then into a triangle. So this is, here is where I could count squares, 1, 2, 3, 4. But really it's a, 4 times 1, right? This is 4 times 1, and then plus 1/2 times, now the width is 1, and then the height of that triangle is 2. So that's 4 plus 1 is 5. The reason it's positive is because it was below, but we were going backwards. Then the integral from 3 to 3, if I plugged in, there, the integral from 3 to 3 is just 0. It's always, whenever we're doing the integral with the same endpoints, right, integral from 3 to 3, that's 0. Then next, I'll use another color. So from 3 to 5, right, 5 is crossing the x-axis. This is just a big triangle. But now we're going forwards, so if it's below, it's going to stay negative. So that's 1/2 times the base is 2, and then the height of that is 6. But then it's negative because it's below the axis. So 2 times 3 is 6, so this is negative 6. Now, to get the next one, right, the integral from 3 to 6, really what you can do is just start off with that negative 6 and then add on whatever's new. So basically that's going to be negative 6 plus this new triangle, which is 1/2 times 1 times, that's a height of 2. So negative 6 plus 1 is negative 5. And again, to get to 9, we would start with what we already had and then add on. But I think it's easier to kind of think of this as a big triangle. So I'm going to do that triangle. And then at 9, we're right there. So we have this rectangle. So I'm going to say, okay, my green was -6. So I'm going to use that. So that -6, then plus that bigger triangle, 1/2 times 2 times 6. And then plus this rectangle is 2 times 6. It'll be -6 plus 6 plus 12, which ends up giving us 12. So those were all integrals. Okay, next, these are all questions that are asking us to kind of look at the graph. So I'm going to go ahead and kind of erase this. And if this was on free response, to explain this, we need to make sure that we kind of say, okay, f prime of x equals f of x, and big F double prime of x equals f prime of x, and then think about what they're asking. But in this case, they're asking for f of t. So they're not even going here yet. They're just asking, where is f of t positive? Well, that's literally just the graph. So f of t is positive literally just right there. So from 5 to 9. I think this graph actually goes to 10. Yeah, this graph goes to 10. You could put 5 less than x less than 10 is probably a little better. Then where is f of t negative? From 0 to 5. And so now it says, on what intervals is big F increasing? Well, big F increasing would mean when is big F prime positive? Well, what is big F prime? Big F prime is equal to little f of x. So these are the same question. It's the exact same question. Then where is big F decreasing? That would be when big F prime of x, which is equal to little f of x, is less than 0. Well, that's the same question here. So 0 less than x less than 5 again. So make sure that you realize those are the same question. Okay? They're never, ever, ever going to ask you, like an AP exam will never ask question 2, and it will never ask question 3. It will always ask question 4 and 5. But you want to know how easy it is to do, right? Just set big F prime equal to little f, and then where is that below the axis, or where is that above the axis? Then on what intervals is big F of x concave up? So big F double prime of x concave up would be when it's greater than 0. Well, that's equal to little f prime of x. Right? So this is the graph we have. That's of the graph. So where is f prime of x positive? That's where the graph is increasing. So where is the graph increasing? It's increasing from 3 to, not to 10, but from 3 to 7. From 3 to 7. So we'd say big F of x is concave up for 3 less than x less than 7. Because, and then I like to do this, big F double prime of x is equal to little f prime of x is greater than 0 for that interval. So I always include both whenever I'm justifying these ones. I always include both. So I write both of those. And where is it concave down? Same thing, but just kind of the opposite. F of x is concave down when that graph was decreasing. So that's for 0 less than x less than 3, because big F double prime of x equals little prime of x is less than 0 for that interval. Right, that's where the graph was going down. Now, what about from 7 to 10? Well, from 7 to 10, it's neither concave up nor concave down. It's neither one. It's probably linear in that section. Next up, a few more questions, kind of similar. Okay, we have g of x equals the integral from 0 to x. So to get g of 8, we do the integral from 0 to 8 of f of t dt. So from 0 to 8 is right here. This is a half circle and then a quarter circle. The half circle is above the axis, so 1/2 pi times and then its radius is 2. It's half of that circle, so the radius is 2. Don't get mixed up into the diameter. That's the center of the circle. So the radius is 2 squared. Then minus 1/4 pi times, now this time, the center of the circle is right here. So this radius is from 4 to 8, so that radius is 4. So one of the 4's can cancel. One of the 2's can cancel. So we end up with 2 pi minus 4 pi. So we get negative 2 pi. So g of 8 is negative 2 pi. It makes sense that we got a negative answer because this bottom area looks a little bit bigger. Do another color. So for g prime of 8, before we can do g prime of 8, we want to figure out what g prime of x is. Okay? So g prime of x, we're just going to plug in x, and we get f of x. So then g prime of 8 is just f of 8, which is the y value at 8, right? And the y value at 8, if we kind of take that over, is negative 4. And we want to do the same thing for g double prime of x. So g double prime of x is equal to f prime of x. So g double prime of 8 would be whatever f prime of 8 is, which is the slope at 8. The slope of that graph, it's a horizontal tangent, would be 0. On what intervals is the graph of g concave down? So remember, we want to kind of connect that g double prime of x equal to f prime of x. You might even want to write that. So it's going to be concave down whenever f prime of x is less than 0, which would be when the slope is less than 0. So when the graph is decreasing. So where is this graph decreasing? I'm going to erase this, make it a little bit cleaner. This graph is decreasing from 4 to 8, and that's it. Oh wait, and from, sorry, that's my fault, and from 2 to 4. So it decreases from 2 to 4 and from 4 to 8. So I will say G is concave down for 2 to 4, union 4 to 8, because G double prime of x equals f prime of x is less than 0 for that interval. Now I separated them because I kind of saw that it is, the slope is DNE here. It's that vertical tangent line, right? So the slope f prime would be 0, undefined there, and undefined there, and then 0 here. So those are my 3 possible inflection points. But if you had combined these and just said from 2 to 8, you would get full credit. Okay, so I did separate them, but just know that if you had combined them from 2 to 8, you still should get full credit. Okay. On what interval is g of x increasing? So g of x increasing would be g prime of x. So we want g prime of x to be positive. Well, g prime of x is equal to f of x. That's just the y value. So we want the y value to be positive. Where is the y value positive? Between 0 and 4, and between 12 and 17. So g is increasing for 0 to 4, union 12 to 17, because g prime of x equals f of x is greater than 0. And then find all values where g of x has a relative minimum. Where do we get relative minimums when g prime changes from negative to positive? Well, g prime of x is equal to f of x, so we want to know where does f of x change from negative to positive. So where on this graph did f of x change from a negative value to a positive value? It only happened one time. F of x changed from negative to positive at x equals 12. So g has a relative minimum at x equals 12 because g prime of x equals f of x changes from negative to positive at x equals 12. Next up, what are the coordinates for each point of inflection? So points of inflection are where g double prime of x, which is equal to f prime of x, changes signs. So f prime of x, that's our slope. Where does the slope change? So where does the slope change from increasing to decreasing or vice versa? Well, if we kind of look at this, it's increasing, then we decrease, then we increase again, and we increase again. So where does the slope change signs? The slope changes signs at 2 from increasing to decreasing, at 8 from decreasing to increasing, and that's it, right? Here it was decreasing, decreased again, increasing, increases again. So only at 2 and at 8. So the other points, right, 4 and 12, those would be possible inflection points because g double prime equals f prime was d and e, right? It had a vertical tangent in a corner, but the graph kept decreasing or it kept increasing. So inflection points are only when it actually does change. So g has inflection points at x equals 2 and x equals, I think it was 8. Right, 2 and 8 we said. Because g double prime of x equals f prime of x changes signs at those points. Brandon asked about should we write it in interval notation or with an inequality sign. And the answer is whatever you prefer. So if you would rather write 0, 4 union 12, 17, you'll get full credit. If you instead would rather write 0 less than x less than 4 and 12 less than x less than 17, you'll also get full credit. So either way is fine. The answer keys actually even sometimes write it either way. It's just a preference. They mean the exact same thing, so you'll get the same points. So it's just whichever way you prefer. A good question. Thank you, Brandon. I appreciate that question. And then I do want to pull up the classwork since I did have to leave a little bit early today. I'm not going to spend a lot of time on it. I just want to kind of peek at it because if you had any questions, I want to make sure that I kind of explain and show it how we would have written it. So in class, we did those 2 AP questions in breakout rooms. Let me pull those up here. So we had questions 4 and 6. And so I'm going to just pull up the scoring guides and kind of look through that really quickly for us. So this first one is very similar to what we've been doing this whole time. G of 3, we just did the area under the curve. I don't think I really need to go over that. The area, triangle, and then a big triangle, and then make sure that you stopped though at -3. Sorry, at +3, and you started at -3. So it actually wasn't that first triangle. It's just this big triangle, and then only to there. Then B says on what intervals is the graph both increasing and concave down? This one's a little bit tricky. Both increasing and concave down. So let me try to download this. There we go. So both increasing and concave down is not something we're used to, but if we do get it, we got to be ready for it. So I would kind of do them one at a time. So, the increasing part, g prime of x equals f of x. Increasing would be when it's greater than 0. So it would be this whole section. Then where is it concave down? That would be g double prime of x equals f prime of x. Concave down would be less than 0. That would be when the graph is decreasing. So that would be this section and this section. So where do those overlap? They overlapped from -5 to -3 and from just 0 to 2. So in this case, they wrote it in inequality form. But, to Brandon's point, had you put -5 to -3, union 0 to 2, you would have also gotten full credit. Now, they wrote it that way. I would have kind of written because g prime of x equals f of x is greater than 0, and g double prime of x equals f prime of x is less than 0, because that's all I did. Okay, and this would be full credit. So if I wrote just this, I would get full credit. C was quotient rule. So it was low is 5x. D high would be g prime of x minus high g of x. D low would be 5 all over low squared. And so the big thing here is just to kind of remember that when we're doing g of, they wanted to find g of 3. Well, g of 3 we already did in part A. It was 9, so we don't have to redo it. And then g prime of 3, that's going to be the f of 3, which is just going to be the y value. So f of 3 is going to be the y value at 3. And right there, and so we get negative 2. There we go, negative 2. So that's all that was happening there. So, 15 times negative 2 minus 5 times 9 from part 1 over 225, right? From 5 times 3 squared. So that's kind of how we got that. You simplify it, you get negative 1/3, but honestly, you leave it like that, you get full credit. So once you've plugged everything in, you don't have to simplify. This would be full credit, and this would be full credit. So the only thing that you're doing is you're wasting your time and you're possibly making a mistake. So I would absolutely leave it here. Now you do have to plug in each number. You can't leave it here because I still have g prime of 3. So I do have to plug in each number, but once I've written each number, you've gotten yourself full credit. And then D said the function p of x equals f of x squared minus x. Find the slope of the line tangent to the graph. So I would have kind of said x1 is negative 1. Then for my y1, right, I would have just plugged in, okay, p of x, so p of negative 1 equals f of negative 1 squared minus negative 1. That's f of 1 plus 1, which is f of 2. So we want to find what is f of 2 here. Well, f of 2 is 0. And for my m, this is where we're going to do p prime of x, and that's where we're going to have a chain rule. So p prime of x, right? The outside is the f, so f prime of x squared minus x times, and then chain rule would be 2x minus 1. Make sure to put that in parentheses. They give you 2 points for this. 2 points just for the derivative, for the chain rule. And then we do p prime of negative 1 is f prime of 2 times 2 times negative 1 is negative 2 minus 1 is negative 3. Then the slope at 2 is the slope of this line. Down how many, over how many, right? So kind of just the rise over the run. So down 2 over 1, down 2 over 1. So the slope here was negative 2. And so then we would have, all they said though, I made a mistake. They didn't ask us to write the equation. They just said find the slope of the line tangent. So we don't have to write out the full equation. It's just that. And then our other guy asked us to sketch the solution curve. So the big thing here is to kind of put in 0, 1. So to put your point there at 0, 1. And from there, you're just kind of following, kind of playing connect the dots. So if it's increasing, increase. It doesn't matter, if your line looked like this, if you kind of maybe connected them a little bit differently, they're still going to give you full credit as long as the shape's the same, right? Technically, the black line would probably be as accurate as you could get, but this, they'd be okay with. It's not perfect, but it kind of follows the pattern, okay? Same thing, if you had kind of done this, they'd still be okay as long as you're following the general pattern, okay? Next up, write an equation for the line tangent. So this is where we are writing our equation. This is super, super important on B. So x1 is 0, y1 is m, and then, is 1, and then m is our dy dx. So our dy dx. So here they had dy dx equals 3 minus y. So 3 minus 1 times cosine of x, cosine of 0. That's 2 times cosine of 0 is 1. Make sure we have those memorized. So we get y minus 1 equals 2 times x minus 0. Now, I would just box that. Okay. On the answer key, they put y equals 2x plus 1. They kind of isolated for y. You don't need to do that. Okay, you absolutely don't need to do that. And then when we approximate, we would do y minus 1 equals 2 times, for x, we're putting in 0.2 minus 0. So y minus 1 equals 2 times 0.2 is 0.4. So you get y is approximately, when we add the 1 over, 1.4. Again, I said you can box that, you get full credit. Or even better, write f of 0.2 is approximately 1.4. Watch out for a question like, is this an over approximation or an under approximation or anything else? But in this case, they didn't do that. Then part C, find the particular solution with the condition f of 0 equals 1. So I'm going to kind of look at theirs, and we'll just kind of look at what they did. So first, they divided both sides by 3 minus y. And then they multiplied both sides by dx. Right? Then they take the integral of both sides. Now, this one is a little bit tricky. Why is there a negative in front? There's a negative in front because of the minus y. So they didn't show it, but I absolutely would recommend u sub here. So dy over 3 minus y equals the integral of cosine of x dx. I would super recommend u sub because it'll help you with that negative. 3 minus y. So the du is negative 1 dy. Right? Negative 1 dy. So I need to multiply times negative 1 and outside times negative 1. So it gives me negative integral of 1 over u du equals the integral of cosine is sine. Then that's negative ln of u equals sine of x plus c. And then plug back in the u. That's where you get to this line. So they didn't show them doing u sub. Technically, you can kind of do it in your head if you're really good at these. But that's okay. And then again, they plugged in immediately. I really don't recommend plugging in immediately. I would not do that. I would wait and I would isolate for y. So I would say negative ln of 3 minus y equals sine of x plus c. Let's divide everything by a negative 1. When you divide c by negative 1, that's going to give us a new c. So negative sine of x, just plus c again. Technically, it's minus c, but we can just write plus c because it works. Okay. Then, if you did write minus c, you'll be fine, though. You'll still get the right answer when you solve for it. Then we'll do e to the power of, e to the power of. We're going to take that c, bring it into the front. Those cancel out. And so we get 3 minus y equals c e to the power of negative sine of x. I will subtract both sides by 3. Negative y equals c e to the negative sine of x minus 3. Then divide everything by negative 1. And again, my c can just stay positive. You can make it negative again, but you can just leave it positive. c e to the negative sine of x. Now, plus 3, right? Negative 3 divided by 1 does need to become plus 3. I think my face is in the way of that. There we go. And so this right here, that's where you plug in. So I'll kind of do this over here. So that's where I would plug in 1 for the y and 0 for the x. So 1 equals c e to the negative sine of 0. Sine of 0 is 0. Plus 3, e to the 0th is 0. So this whole thing goes to 1. Sorry, e to the 0th is 1. So that whole thing goes to 1. So we get 1 equals c plus 3. Subtract 3, we get negative 2 equals c. So our answer is y equals negative 2 e to the negative sine of x plus 3. Now on their answer, they just moved the 3 to the front. You don't have to do that. There's your answer. Now I want us to look at, really pay attention to how the AP grades this. Okay? This is really crazy, but it's really illuminating for you to realize this. This is worth 6 points. Okay. Drawing this graph slope field was only worth 1 point. So this part C is worth 67% of your points. You really, really absolutely need to know how to do these. And it just, the points add up so much, and this could be like make or break of you passing the exam, or of you getting a 5 versus a 4 on the exam, you getting a 4 versus a 3 on the exam, because it's so many points just right there. Okay. Hopefully this helped, and this helps you guys out. Brandon says that I made a mistake because -2 times -3. Did I just say it wrong? Did I write it out right, Brandon, or did I actually write something wrong? So, somewhere, I guess there was a -2 times -3 that I messed up on. Oh yeah, -2 times -3 is +6. Oh, okay. I never finished this. Thank you, Brandon. I circled -2. -2 was that, and then times -3, so our final answer was +6. Thank you, Brandon. I appreciate that. So, going back and fixing that one, right, and that's what the answer had anyways. So, hopefully this helped you out. The test will be tomorrow. It's not going to be anywhere near as long as this, but I just figured I'd give you a lot of practice questions because I wanted you guys to have more than enough to study for. Okay, but the real exam will be 7 multiple choice and then 1 free response. So your free response will either be a differential equation like this, or it will be the kind of graph of g of x equals the integral like this. It will be one or the other. And then whichever one is kind of focused on the free response, then the multiple choice will probably have more of the other questions. So for example, like if I have this, then I'll probably have like 2 multiple choice slope fields questions. Or if this is our free response, then we probably won't have any slope fields and any of these in the multiple choice. The multiple choice will probably focus more on kind of this FTC on U sub. There will definitely be a U sub question on the multiple choice, and there will definitely be one of those exponential growth questions on the multiple choice. And then if you are watching this far, okay, and you've watched all of this, there will be a bonus, and there are actually 2 bonus questions. I'm going to be a little bit nice here. So one of the bonus questions I already posted about earlier on the Google Classroom. It had to do with Baxter's middle name. And then the other bonus question will be what month Emerson, my daughter, was born in. And she was born in the month of October. She was born on October, in October a few years ago. She is almost 3. It's crazy. I can't even believe that. So she was born on October 7th, but it's just going to be the month. Okay. So anyways, have a good day. Good luck studying. And I will see you guys tomorrow for the test.